going to show you a large scale testing coil, which I did. Okay. Okay, what you're looking at there are two 18-inch pieces of 12-inch PVC. There's one on the top and one underneath there that it's sitting on. The thing in the center is the tub that goes under a whiskey barrel planter, which it has rollers on it. I took the rollers off, and it happened to be the right diameter to build the L1 coil on. And of course it was black, so I changed the color on it. And this particular one has an output of 400,000 volts. And it has quite a bit of amperage also. The instrumentation that you see below down there, you see the little 12-volt battery sitting beside it. So it's very obvious that if you take what's out and what's going in, that there's a very large difference between the two. I'm going to show you one which was built to demonstrate over unity. If you have separate coils which are no way connected except through the magnetic flux that are tuned to the same frequency of the output, when in the center here you have the output coil, and you see the L1 and the ring around it, and you see the L2 in the center, and its the tuning parts are right here. See the variable capacitor? It's a variable mica capacitor, and then there's a variable resistor here, which is in part of the circuit. So that goes back to the circuit I showed you, the over unity thing a while ago, where you had a resistivity in there, but when this thing becomes resonant, of course the resistivity all becomes negative, and therefore you've got energy which greater than what you had to begin with. So anyhow, this thing behaves exactly like a radio broadcast station, a very simple radio broadcast station, about 18 and 11 or somewhere along through there. These other coils are tuned to the same frequency. So being tuned to the same frequency, this thing, say, puts out 100,000 volts at a certain amperage. Well, these, regardless of how many of these you put around there, if they're tuned to this one, they're not going to take away from the voltage that's there or the energy that's there. They're going to duplicate it. And the reason is that the electrons that are active here are not the same electrons that are active here. Through resonant frequency, those coils are tuned so that they react just like if someone taps you on the knee and your foot goes up, sort of deal. It's now 10:10, and let's see, I think we're scheduled to break at 10:15. People think that the electrons go from point A to point B. That is not true at all. The electrons are activated at point A, and electrons move tremendously slow speeds. So the electrons which are at the generating station in your village are not the electrons which are at your house. When you turn your house switch on, you're grounding the system that is connected, and the electrons at your house start acting up, and that's where you get your energy at your house. It does not come from the power company. And with that, I believe we'll go ahead and take a break, and we'll come back, and we're just getting started. Okay? Very. Okay, can we go to the overhead in just a moment? seem to be getting anything on the overhead. You see it? Okay. Those of you that are asking what the basic circuitry on these things boil down to, well, this one is probably easier to understand than some of the ones that we've been looking at. But the basic idea is present in this schematic. You see your number 5 is your L1. The 3 there, or the first block, the large block that's up parallel with the number 5 to the left of it, would be your high voltage transformer, whether it's a laser module or whatever. And the spark gap, number 4 there, would be the lightning arrestor, which I showed on the other device. Then you have a voltage limiting device, which would be number 8 is the voltage limiting device on that particular thing to keep it down at a level which you can manage. There's only one diode showing in this case, which is sending forward pulsating DC, a kind of a sawtooth type deal. By hooking another diode down on the bottom corner there and whipping it back up to the in front of where the number 9 is now, going towards the transformer, you would have smoothed out pulsating DC, which is what you really want to go forward to your transformer. Number 10 is matching the transformer to the frequency which you want it to run at. Once you've taken the measurements on number 11 there on the input side, you can calculate what number 10 will be, which will give you your 120 cycles per second, which is 60 up and 60 down, which is your 60 cycle electricity, which you're normally accustomed to. Number 12 is a voltage control to keep the thing from running away from you and burning the transformer up and those things. There are many, many different ways to go on this. Another way would be to go with toroidal transformers, and that's what I'm going to show you next. The same situation set up with a bank of toroidal transformers. And there's almost no end to the types of things that you can come up with, and they all seem to work fairly nicely.